Hello everyone. It is our pleasure to present our project focused on the automation of an industrial sorting station using a programmable logic controller or PLC. This work was carried out as part of our training in industrial engineering at the HEPL and aimed program a fully automated sorting process. The objective of this project was to develop a system capable of sorting parts efficiently, accurately, and reliably. Throughout the development, we applied our knowledge in functional analysis, PLC programming, sensor and actuator integration, and human machine interface or HMI design. The team is composed of 4 industrial engineering students from the HEPL. On this picture, you can see the real sorting station we have to program. In this station, we have several actuators, such as 2 pivots, 1 belt conveyor and 1 jack. This station is also composed of 6 sensors, such as 2 photoelectric sensors, 1 inductive sensor, 1 retroreflected sensor, and 2 inductive sensors for the pivots. The first case we'll present is the normal functioning case. When we turn on the machine, the operators must select the version of the program for the real station or the simulated station. Once that's done, they'll have to click on the OK button on the HMI and push the start button to turn on the station. The parts must be pushed one at a time to make sure we can well sort them. Once the part is next to the jack, 2 photoelectric sensor and 1 inductive sensor will sort in which line the puck has to go and therefore turn on the right pivot. When the line has 2 pucks, a warning is triggered to tell the operator that the line is almost full and he must empty it. When the line has 3 pucks, the station stops and an alarm turns on to tell the operator that the line is full and he must empty it before restart the station. Once he has emptied the station, the operator must reset the counter of puck per line and push on the start button to turn back on the station.
The pause button is used to temporarily stop the system, but only after the current operation is completed. For example, if a box is already moving and the sorting arm has been activated, pressing pause will not stop the action right away. The box continues its path, is correctly directed onto the appropriate place, and then the system pauses. At this point, the arm remains extended and the system transitions into step A4 of the JEMA model, cycle interrupted. No new boxes are processed and the system remains on hold. This function is useful when you want to pause without disrupting an ongoing action. It ensures everything stops in a safe and stable state. To resume the cycle, the operator must press the start button, which moves the system back into normal operation. It's a smooth and safe way to intervene or inspect without stopping everything abruptly. The stop button is used for emergency situations. When it's pressed, everything comes to a sudden halt. For example, if a box has just passed the sensors and the robotic arm is about to sort it, pressing stop will immediately cut the power to the main conveyor. The box stops moving and the arm retracts. No further action takes place. At this point, the system enters step 6 of the JAMA model, emergency stop. On the HMI, the red ACK light starts flashing, indicating that an alert has been triggered. To proceed, the operator must go to the ARU Alerts tab and manually confirm a checklist of safety points, for example, verifying that there is nothing blocking the pusher. Once all 5 confirmations are checked, the operator must press the ACK button on the machine. This acknowledges the stop condition and moves the system back to step A1 of the JAMA, initial state. From there, the system can be restarted by pressing the start button again. This process ensures that any emergency situation is properly handled before resuming normal operation.
So the procedure to switch from automatic to manual mode is that we need a default to be able to switch to manual mode. Here we are going to simulate the pivot 1 that is not in the initial position so that the process cannot start. We have a default, we are in a D2 state of the JAMA, and we can press the switch to manual mode and we can control independently every module, which are pivot 1 and 2, the pusher or the conveyor. Once we are all clear and the machine is set back to continue, we can reset in the initial state, switch back to the auto mode and acknowledge the defects. This will bring back the machine to the initial mode as called A1, and then we can start again to be in F1. The first default here is the same as we showed earlier. I will the pivot 102 that is not in initial position. We are showing again the procedure where with all the alarm, we hear the alarm view and the acknowledge of the alarm. We're then going to acknowledge and see that the machine is set ready to start again. The second default that we're going to simulate here is when boxes has gone through the first sensor and is on the conveyor to be sorted, but the boxes disappeared or is removed by an operator or some kind, and that it never reached the end sensor, so we know that it wasn't sorted correctly, and we have set a time where we have an alarm from this moment. Here where we can see that the conveyor is clear, we can acknowledge the defects and press start to continue.
The integrated web server allows users to access real-time PLC data directly through a standard internet browser, without the need for additional software. Once enabled in the TA portal, it becomes possible to design custom HTML pages that displays input-output statuses, performs system diagnostics, and monitor key process variables. Security is also taken into account with configurable access levels and password protection to ensure that only authorized personnel can interact with sensitive data. On our web server, we get access to the JAMA state, the counters, but also the status of our actuators such as the belt conveyor or pivots and the pusher blade. On the other end, the OPC UA network, short for Open Platform Communications Unified Architecture. It offers a powerful unified communication protocol designed for industrial automation. It stands out for its vendor independence, robust security, high reliability, and flexibility, making it the ideal for scalable and future-proof architectures. OPC UI also integrates seamlessly with engineering tools like Simulink, enabling advanced data visualization and protocol. In our project, the dashboard we developed closely resembles the functionality and interface of traditional HMI, and thanks to Simulink flexibility, we were able to enhance it with custom icons and visual elements tailored specifically to our station, improving both usability and clarity for the operator.